Hi, in the previous video we saw a method of solving equalities, and that method was outlined here, and we applied this method to this example and we found this solution. Now we'd like to see whether this solution is correct. In other words, we'd like to confirm our solution, and we do this by plugging in. We'll apply the same method, but in this case there is only one major step. We only have to do PEMDAS. There is no unknown anymore. After we plug in, there is no x, so there is no need to cross the bridge or isolate, so no properties of equality will apply here. Okay, let's plug it in. Now I rewrote the equation, the original equation that we had over here. I rewrote it, and now I'm going to plug in. The way we plug in is we replace x with parenthesis -2. You have to put the parenthesis, otherwise you'll make a mistake and you'll write it you'll write it incorrectly in math. According to the math syntax, what you're gonna write is gonna be incorrect if you don't put the parenthesis. In general, every time you plug in, you can put this number in a parenthesis. If it's 3 plus x and the x is positive or minus x, then you don't have to use a parenthesis if it's plus or minus x. If it's x equals 5, for example, you get 3 plus or minus 5. There's no confusion. The confusion is when you have 3 times x. If the x is, even if the x is positive, you may actually write it as 3 plus 5, and you may actually add instead of multiplying. If you put it in a parenthesis, you'll be forced to multiply. If it's negative 5, and you write it as -5, again you'll be forced to you'll be misled to subtract, whether you have to actually multiply. And some other times I see this written 3 times -5. This is wrong syntax in math. You never put two operation symbols next to each other without a parenthesis. Okay, that's a little side note. Let's just apply, and what we need to remember is that x will be replaced by parenthesis -2, and everything else drops. Okay, so let's do that. Now 3 is going to drop, minus drops, 2 drops, times drops, parenthesis drops. Sometimes you can put this in a bracket because there's going to be another parenthesis inside, but I'm just going to leave it as a bigger parenthesis. 4 times, here I'm going to put parenthesis -2, minus 5, closing, equals drops, 14 drops, plus drops, 5 drops, parenthesis drops, 1 drops, minus drops, minus 2 replaces x, parenthesis drops. So you see here is two negatives, negative, negative. One comes from the already existing negative in the equation, the other comes from the x. Okay. Now, as I said, we would just do the same method, meaning PEMDAS to the left, PEMDAS to the right, and we don't need to do anything else. Okay, let's check. Do I have a parenthesis? Yes, so I go inside the parenthesis and I apply a little PEMDAS. Do I have parenthesis inside the parenthesis? Yes, but there's nothing to do, it's just a single number, so it doesn't apply. Do I have exponents? No. Multiplications? Yes, here. It's 4 times -2. And this is what I'm going to do. Everything else drops. So 3 is going to drop. negative is gonna drop, 2 is gonna drop, times parenthesis drops, and see what happens on the inside. I just do the multiplication, which is 4 times negative 2. Now 4 is positive. Positive times a negative is a negative. 4 times 2 is 8. Then this negative and this 5 drop, and I get negative 5. Okay? That's it on the left. Let's see what happens on the right. To see what happens on the right, I'll apply another PEMDAS to the right. So just to go back before I forget, on the right, on the left, we actually did the parentheses. Okay, on the external PEMDAS, and on the inside the parenthesis PEMDAS, we did the M. Now we go on the right, and we have the external PEMDAS that governs the right hand side. Do I have parentheses? Yes. Let's see if there's anything to do inside the parentheses. I put a little PEMDAS inside the parentheses. Do I have parentheses inside the parentheses? Yes, here, but there's nothing to do. It's just a number, so no parentheses, no exponents. Multiplication. Do I have a multiplication? I really do, but it's hidden. This negative, the negative 2 is really negative 1 times negative 2. So I actually have a multiplication. So since there is something to do inside the parenthesis, I do it, and on the external PEMDAS I work on the P. Okay, everything else is gonna drop except for this multiplication. So 14 drops plus 5 parenthesis drops, 1 drops. Now I have negative 1 times negative 2. Negative times a negative is positive. 1 times 2 is 2, and that's it. Let's go to the next line now on the left. New line, new PEMDAS. Do I have parentheses? Yes, I do here. Let's see if there is anything to do inside the parentheses. So I'm going to write a smaller PEMDAS. Do I have parentheses inside the parentheses? No. Exponents inside the parentheses? No. Multiplication inside the parentheses? No. Division? No. Addition, subtraction? Yes. Therefore, there is something to do inside the parentheses, so I'm still on the letter P. Let's do this, and everything else drops. 3 is going to drop. Minus 2 times parentheses. I have to combine those numbers, negative 8, negative 5. They're both negative. They have the same sign, so they're added. 8 plus 5 is 13. Because they're both negative, this is a negative 13. And let's see what happens on the right hand side. I'm here now. New line, new PEMDAS. Do I have parentheses? Yes. Let's see what happens inside the parentheses. Little PEMDAS. Do I have parentheses inside the parentheses? No. Exponents? No. Multiplication? No. Division? No. Addition, subtraction? Yes. I have addition, subtraction, and I can do it. They are like terms, they are numbers. So I'm doing addition, subtraction. Therefore, I'm still on the letter P. Okay, everything else drop except for this addition. So 14 is going to drop plus 5 times. I'm going to use the parenthesis even though it's a positive number. 2 plus 1 is 3. The advantage of that is that if you forget to put the multiplication symbol, the parenthesis is going to remind you. If you forget to put the multiplication symbol and you just write 3, you may read it as 53. Or if you write plus 3, you may add them, and you're not supposed to add here, you're multiplying. So let's just put it for now inside the parenthesis to avoid any confusion, and let's go to the next step. Okay, so we're gonna do PEMDAS on the left and PEMDAS to the right on the next line. Let's write our PEMDAS here. Do I have parentheses? Yes. Is there anything to do in here? No, it's just a number, so no parentheses. We're moving on. Exponents? No. Multiplications? Yes. So here we are working on the letter M, and we're doing this multiplication. Let's see. Well, we're just going to multiply those two numbers. Everything else drops. So 3 is going to drop. And then we have negative times a negative. It's going to give me a positive. 2 times 13, 26. A common mistake here is instead of multiplying, you subtract. 3 minus 2, 1. But that violates PEMDAS, so that would be wrong. Okay, now let's see what happens on the right hand side. I put a new PEMDAS. And let's check. Do I have parentheses? Yes, but there's nothing to do in this parenthesis, already done. So no parenthesis, no exponents. Do I have a multiplication? Yes, here. Even though there may not be the multiplication symbol, there's still a multiplication. Okay, so I'm going to do the M. And here is easy, just those two numbers, 5 times 3. Okay, everything else drops. So the 14 is going to drop. And we have plus 5 times 3 is implied to be plus. Positive times a positive is a positive. 5 times 3 is 15. And we're on the next line. Let's go on the left. New PEMDAS. Parentheses. No. Exponents. No. Multiplication. No. Division. No. Addition, subtraction. Yes. Are they like terms? Yes, so I can add or subtract, and this is what I'm going to do. Addition, subtraction. And there's really only one thing that survives. 3 plus 26, 29. So I only have one number on the left, and that is 29. Let's go to the right now, and let's do PEMDAS. Do I have parentheses? No. Exponents? No. Multiplication? No. Division? No. I have addition, subtraction? Yeah, I have addition. Addition and subtraction basically go together. They can be done interchangeably in the same way as multiplication and division. Yes, I do have addition and subtraction. Let's do it. 14 plus 15, it's 29. And now that I have a single number on the left and a single number on the right, I stop. There's nothing else to do. That is a true statement. So my solution is confirmed. And that's it. So bottom line, I used the same method, but only the first part of it. I didn't have to cross the bridge or isolate because there was no unknown, there was no x. I just did PEMDAS to the left, PEMDAS to the right, and I plugged in using a parenthesis, especially if it's a negative number, and I arrived to a true statement. 29 is equal to 29. That's a true statement, and that confirmed my solution.